Good morning, Year 11s. Welcome to a video on function notation. Hope you're sitting down, nice and comfy, ready to take notes. Alright, essentially, function notation is an alternative for y equals. In the past, you may well have seen y equals 2x plus 3 for drawing a straight line graph. That is exactly the same mathematically as f of x equals 2x plus 3. Essentially, we can replace this little y here with an f of x. Function of x. Why do we bother doing this? Well, it comes useful with substitutions and when we have many functions that we want to nest together. Alright, so right now it'll look like an annoying semantic shift where we've just swapped out y, put in f of x, and that's a pretty good way to think of it for now. Later on, it'll become a little more complex. But let's consider this. If f of x is equal to minus 2x squared plus 3x takes 6, find f of 2. Now, f of 2 is very simply saying, well, substitute 2 into the x side. So you see here how it was x, now it's a 2. Great. Everything here that was an x now has to be a 2. So minus 2 lots of 2 squared plus 3 lots of 2 minus 6. Minus 2 lots of 4 is minus 8. 3 lots of 2 is plus 6 minus 6, just leaves us with minus 8. Alright, now note how I'm putting the 2's in brackets as we substitute in. So where it was an x, I'm putting in the substitution in brackets. And the reason I do that is so that if we substitute in negatives or multiple terms, it still comes out okay. So for example here, let's give myself a little more space, what we're going to do is sub in minus 3. So this becomes minus 2 lots of minus 3 squared plus 3 lots of minus 3 minus 6. Minus 3 squared is positive 9 times negative 2 is negative 18. That there is negative 9. Oop, that's not a 9. 9 minus 6. Minus 18 minus 9 is minus 27 minus another 6 is minus 33. At one point I will make a mistake in these videos, which is great because it's caught on camera. Alright, f of x plus 2. What that's saying is we're taking out the x and we're putting in an x plus 2 in its place. And clearly we're not going to come out with a number, but we can expand and simplify and we'll come out with a different function. So minus 2 lots of x plus 2 squared plus 3 lots of x plus 2 minus 6. Alright, let's expand and simplify that. Keeping minus 2 at the front here, this then becomes x squared plus 4x plus 4 plus 3x plus 6. That's that expansion happening, take 6. Let's expand this first one. Minus 2x squared, take 8x, take 8, plus 3x plus 6, take 6. Alright, the plus 6 and take 6 on the end are going to fall off. This minus 8x is common with plus 3x, so it becomes minus 2x squared minus 5x take 8. Alright, and that would be the simplified answer. So essentially, function notation is enabling us to rip out x from inside a function and replace it with something else. That might be a number or a letter, but we should be able to make that substitution and then work it out from there. So this can reduce the type of questions that look like this. Find a linear function in the form y equals mx plus c such that f of minus 1 equals 6, f of 2 equals minus 4. Now to visualize what's happening here, that was meant to be a full axis, f of minus 1 is 6. Say minus 1 is here, and 6 is there. When x is minus 1, y is 6. That is describing that point there, the point minus 1, 6. F of 2 is minus 4. F of 2 is minus 4. Is describing that point there. And what this is really asking is for us to find the equational line between those 2 points. Alright. So, in function notation it looks scary, but essentially it's reduced itself to what's now a Year 9 problem. We'll do it just for our own amusement. First of all, with these ones, you find m, which remember is y2 take y1 over x2 take x1, or think about it as rise over run. In our case here, the rise is from 6 to minus 4. The rise is negative 10. Over the run is going to be from minus 1 to 2 is 3. The slope is minus 10 on 3. So far we have y equals minus 10 on 3. And if you substitute values into y1, y2, etc., you'd get minus 10 on 3. X plus c. Now remember, c is where we hit here. That's what we're asked to find. And in order to find that, what we can do is make a substitution. So we can substitute in a point that we know already. Let's choose the first one. The first one is saying when x is minus 1, y is 6. 6 equals minus 10 on 3 minus 1 plus c. 6 take 10 on 3 equals c. 10 on 3 is really 3 1/3. 6 take 3 1/3 is 2 2/3. So the equation we're after is y equals minus 10 on 3x plus 2 2/3. And even though my scale is absolutely terrible, you can sort of imagine that yeah, could be realistic. Alright, so there will be plenty of other examples of class of how we use function notation. The important thing to remember is that f of x is really just a substitute for y, and that we use it to show how we substitute values into where the x should be. Alright, thank you very much.